All right, welcome everyone to the eighth meeting of TC54. We have a pretty light agenda today as opposed to last week. There was one agenda item that we had to move to the next week because Daniel is not here this week. But before we get into that, are there any new people on the call that have not attended a TC54 meeting prior? I don't see anyone. Okay. Well, let's go ahead and get started. A real quick update on CycloneDX. Everything's frozen. It is release ready at this point. We are just waiting for the documentation, which is the guides. We've got 3 new guides that are coming out. We've got an authoritative guide to xBom, authoritative guide to attestations, and the authoritative guide to xBom 2nd edition that will be published next week. The other paperwork that we're working through is a press release that will go out either Tuesday or Wednesday of next week. We are currently waiting for approvals from some of the quotes that are going into that press release. So other than that, we are ready for launch. So this is truly exciting. The community has done a lot of hard work. Many of you have been part of that work. So thank you very much for that. One of the prior asks was to kind of review the entirety of the specification. So without further ado, I think it would be great for us to kind of dive in and look at the documentation. What is CycloneDX specifically? And this is not for my benefit. This is really for the community's benefit, so that we all have a collective understanding of what exactly is CycloneDX, what does it do, what does it not do, so that we have a really firm understanding of it when we recommend this for the standardization process. Let's and please stop me if you have questions or whatnot. Again, this is not for my benefit. This is for the community's benefit. Where's my share? And then there we go. So this document right here is dynamically generated from our JSON schema. Our JSON schema is the source of truth for the human readable specification. The first 2 sections in this, and before I get into that, I guess I should note that there's a few remaining things that we need to do to the script to get it to generate complete documentation. And there's a few outstanding known things in terms of incomplete documentation, but we're not going to get to any of those today. As such, we're going to be kind of checking off our progress by using what is referred to in the documentation as location, which is essentially a breadcrumb of where the data field appears in the specification. So we'll be using that rather than page numbers or section numbers to kind of track our progress, because each time we dynamically generate this, it could vary by a little bit. So just kind of keep that in mind. Now, the first 2 sections, the introduction and the object model, these are taken straight from the authoritative guide of xBom, specifically the 2nd edition, which will be published next week. These are not part of the specification, but I think it would be helpful to kind of just review them quickly before we dive into the specification itself. Okay, let's
Great idea. Love that.
All right. So while the world has been focused a lot on xBom and depending on who you talk to, xBom consumes pretty much all the oxygen in the room. There's a lot of other types of ways that you can be transparent about not just software, but other types of related things. Software as a service, right? The software hasn't lived in a bubble for 20 plus years. Software routinely interacts with its environment, calls out to the internet to fetch stock quotes or check for updates or whatever the case is. So services are a natural part of CycloneDX's inventory. And then, of course, if you strip away all the software components, you're left with basically a SaaS BOM. That's what that is. Since 2018, CycloneDX has supported hardware components as well, because one of the use cases that I had dating back to actually 2012, 2013 was I was inventorying all the components in server appliances, right? These were things that my employer would sell into companies that would deploy them to their data centers. We would call those antiques now. But basically, I had the requirement of being able to track the hardware, the firmware, the operating system packages, the application libraries, the full stack, right? So CycloneDX kind of took that early requirement that we had and supported hardware and software from an early stage. More recently, we've added support for ML. I think that came in version 1.5, and the way that we support that is through the standardization of a formal model card format. It's fairly robust, and then with some of the changes or enhancements that Matt Rutowski has made in 1.6, it's even better. We have in this release of Cyclone 1.6, we are introducing the world to cryptography bill of materials. This was pioneered by some folks at IBM Research that whose primary use case was post-quantum cryptography readiness, being able to have post-quantum safe systems and applications. Obviously, there's other use cases for this as well, but PQC was really the driving factor for xBom. Obviously, software is deployed. It's put in operation somewhere. So we support the concept of an operational bill of material. This is really what is all the things that are in play, not just a software that you purchase from a supplier, but what is everything in play to get that software into operations, right? Is it deployed on a Windows or Linux server? What is the hardware on that thing? What is the configuration for these things, right? All that can be captured in an OBOM. Manufacturing bill of materials. This is really the concept of how something came to be, right? It could be how software was created, how software was tested or deployed, how a machine learning model was trained, fine-tuned, evaluated, or how an IoT toaster, right, was designed and manufactured, right? So this is really the concept of how something came to be. Bill of vulnerabilities. The basic premise of this is being able to share vulnerability data between different systems, right? This is really the only format that does this today. We've got the CVE format, but it's very, very specific to the CVE process, and CNAs are part of that process. You got OSV, which is very confined to open source, which is great, but it doesn't capture all vulnerabilities. But if you truly want to share vulnerability data between different systems, CycloneDX is actually a really great way to do that. One of the primary requirements of supporting vulnerabilities is to be able to disclose vulnerabilities to another party, right? It could be, for example, a internal pen test team or red team that is saying, hey, I found vulnerabilities in your software engineers. Why don't you fix it? Or maybe it's a third party penetration testing firm, right? And what do these firms typically do? They typically generate PDFs, and they give those PDFs to the development team, and the development team throws them back and ignores them because they're not in Jira, right? They can't take action on a PDF. CycloneDX was really designed to reduce the time that the engineers can action upon the vulnerabilities that are discovered in the software that they're responsible for. If you flip that around, vulnerability exploitability exchange is really about, hey, these are the vulnerabilities that we are not exploitable to, right? Just because I might have a vulnerability in my software doesn't mean that, or in one of my third-party libraries, excuse me, doesn't mean that it's actually exploitable in the context of the application that I'm responsible for. So Vex is a way to communicate things that, hey, I'm either not or possibly even exploitable to particular vulnerabilities. CycloneDX attestations is also new in 1.6, along with xBom. So xBom and attestations are the two big features of 1.6. Attestations is really interesting, but there wasn't a way, surprisingly, there wasn't a standard to represent other standards in a machine readable format and to be able to attest to the requirements of those standards also in the machine readable format, right? There's Word documents, there's PDFs, there's industry specific formats, but there wasn't a general purpose, non-security specific format to kind of represent all this data, which was really interesting. So we had an opportunity there. Again, this is really going with the whole software transparency kind of movement, right? A bill of material is one way to be transparent, but there's obviously multiple different ways to be transparent, and this is another one. And we have a common release notes format as well. So some organizations are actually digitally transforming the way they author and publish release notes, which is amazing, right? Because release notes, in a lot of cases, actually do contain security related things. Maybe not things such as, I fix this vulnerability, which can be in a release note, but more granular type of things, right? For example, upgrade notes. Hey, you might want to change this configuration option when you upgrade to this release because of X, Y, and Z, right? It's that type of data that we wanted to capture with release notes, and some organizations are doing that today. Okay, so that was basically the explanation of all of this. In terms of how we codify this at a high level, CycloneDX is broken down into these nice little colorful things. Starting with metadata, which really describes what the end product is and what the bill of material is. Like, who is the supplier of the bill of material? Not of the component, but of the bill of material itself. Who is the manufacturer of the bill of material? Who are the authors and tools that created the bill of material? What is the component that we are describing with this bill of material? And what are the life cycles, like SDLC type of life cycles or SAM life cycles, software asset management life cycles, that were involved in the creation of this bill of material? Components, this is either the metadata component, which is, again, what the bill of material is about. But components right here is really the inventory. This is the inventory of all the other things that are shipped with that particular product, right? So this could be all of my first-party code. It could be all of my open source and all of my proprietary libraries as well. So who is the supplier for those? What type of component is it? Is it library? Is it framework? Is it a machine learning model? Is it a cryptographic asset? What is it? What is the identity of that component? And we've got multiple ways to express identity. And this is one of the core things that really separates out like other competing BOM formats. CycloneDX actually asserts identity of components and allows you to then substantiate why you are asserting that. The other format, for example, it doesn't assert the identity of a component. It according to the spec, I believe it says believed to be relevant. Well, that's the opposite of an assertion, right? So in CycloneDX, we assert with the bill of material that this is this component, which is really important because when you think about assertions, think about like a physical supply chain, right? Think about a pallet full of widgets, right? A box full of widgets. And on the box, you have a UPC label. And you scan the UPC label and you know exactly what's in the box because you asserted what is in that box. The other competing format, for example, it wasn't designed for this kind of use case. So it doesn't assert what the components are. Rather, instead of having a single UPC label, you might actually have 5 or 10, and they're all different. And you have to figure out which one is in the box. There's only one thing in the box. And for those types of intellectual property and whatnot use cases, that approach might be fine. But for inventory, it's a non-starter. You need to be able to assert a component, and CycloneDX provides the ability to do that via a package URL, via CPE, SWID, and then new in this release is Omnivore and software heritage IDs as well. So you have multiple ways to assert the identity of a component and simultaneously substantiate why you are asserting that identity through evidence, which is also part of a component. Evidence also has the ability to capture not only the identity of a component, right? I believe this component to be X because of all this analysis that I've done in the evidence, but it also has the ability to say, well, here's all the licenses that I've discovered, or here's all the copyrights that I've found. I'm not asserting that this component has this copyright, nor am I asserting that this component has this license, but this is the evidence to substantiate my assertions for the copyright and for the license. Pedigree, this is the concept of, being able to fork components. Open source, for example, is the ultimate supply chain, right? Components are modified and renamed and redistributed ad infinitum, right? And CycloneDX recognizes this reality, and we give you the ability to document what were those changes, why did you make those changes? Was it to add new features? Was it to backport security fixes? Was it because you needed to do something else? And we give you the ability to specify that. Provenance. This is kind of a requirement for example, for SSDF. The NIST Secure Software Development Framework. You need to be able to track the provenance. Where is the origin, the chain of custody of all your components? Where did they come from, right? So we handled that as well. And then we've got a ton of different types of relationships in CycloneDX. Moving on to services. Services are a little bit different, right? Services don't really have an identity like a component does, right? They have a URL a lot of times, not all the times, but most of the times, when you think of like web services type of thing, they typically have a URL, but there's no standard way to identify service, which is really interesting. But we do have providers. We do have endpoints, and these are typically URLs. And we have the concepts of data classifications, as well as the directional flow of data, right? Is this data coming into the service? Is it going out from the service? For example, if you've got personally identifiable information, well, if that's coming from a component to a service, well, that's interesting to know, especially if the provider is not you, right? So CycloneDX gives you the ability to document this. When you tie the components and services together, you can then create dependency relationships, right? This component depends on this other component, which depends on this other component, which might actually depend on this service, right? So you can tie all these things together in a fairly comprehensive dependency graph. With compositions, you can describe the completeness of these things. Now, if you're developing software and you're using third-party components, you kind of know like how complete your BOM is going to be. But what if you're including perhaps a commercial library or something that you have zero visibility on? Well, in that case, you might request the vendor to provide you an SBOM for that. But if they don't, well, you really don't know what's in that thing, right? It's kind of a black box. So you have the ability to say, well, I don't know what's in that thing. I know I have it, but I have no idea what's inside of it. And that's the concept that NTIA came up with a few years ago called known unknowns, right? I don't know what's in that thing. So this is kind of a way to describe the completeness, not of just the inventory, but also the dependency graphs of services, components, your dependencies, and you can also describe the completeness of vulnerabilities. For example, if you're asserting with a VDR, if you're asserting these are the vulnerabilities that I have, you can mark that as complete, which indicates to the consumer that this is an assertion of all the vulnerabilities that exist at one given time, right? Which is the opposite of VEX. For vulnerabilities themselves, obviously we've got the details, we've got the which is description and that sort of thing about the vulnerability, whether it's a CVE, etc. We've got the source, who created the vulnerability, right? Whether it was the NVD, it might have been Sneak, which has their own research team, or Sonatype, which also has their own research team. And many of these commercial SCA vendors, for example, part of their value proposition, right, is in their research teams because they're looking for vulnerabilities that are hard to find. And in a lot of cases, those things are not in the National Vulnerability Database, right? There's tens of thousands of known vulnerabilities every single year that are not in the National Vulnerability Database, right? The NVD is the kind of the least common denominator. So, but you have multiple sources of vulnerability intelligence, and many of those sources are commercial. So we give you the ability to specify the source. We also provide the ability to do risk ratings, right? This was kind of our version of VEX before VEX was a thing. This is really the concept of, well, the NVD says it's CVSS 9.0, which is kind of critical, but, I've assessed it, my organization has assessed it, and this is like a, 4.0, right? This is like a medium severity thing. This is not critical. This is moderate. So we give you the ability to do that, as well as provide things like OWASP risk ratings, which allow you to specify, the risk of using that component in the context of the application in which it's running, right? We do support exploitability. We do have evidence of the vulnerability, target versions and version ranges. So target components, target services. This is kind of important, right? The NVD is really focused on three things. Well, according to the CPE spec, applications, operating systems, and hardware devices, right? Those are the three things that CPE does. And basically, it's all software and hardware devices. But notice it's services, right? The cloud cannot be represented in CPE. CycloneDX can represent vulnerabilities against services too. We also have proof of concept as well as recommendations. So if you wanted to provide like a proof of exploit, so if you wanted to integrate, for example, a workflow where you're capturing data from HackerOne or some other type of provider like that, and to be able to communicate that out to others in the supply chain, you actually can do that with CycloneDX very easily. Formulation, again, is the idea of how something came to be. This is this is kind of broken down into two different but very related concepts. The idea of here is what I declare to have happened, right? Think of a recipe card, right? Your grandmother's recipe. Well, in order to bake these cookies, I need to follow these 5 steps, right? Versus what actually transpired in the kitchen, right? Which might be different than what you had on that recipe card, right? So this is both the declared as well as the observed formulation for how something came to be. And we do that through a series of formulas, right? Each formula can contain workflows and tasks and different steps. And then, of course, each one of these steps could involve a component or a service being part of that process, a hardware device, a piece of software, right? A cryptographic algorithm to sign something can be part of the formula that makes up how something came to be. Annotations. This was actually one of the manual use cases that the other spec kind of grew up in an age of manual type of use cases, right? Lawyers looking at things, making comments on things. CycloneDX grew up in an entirely different era. DevSecOps, complete automation. Manual use cases were not one of our focuses. However, there's a lot of value in, especially for the legal side, actually having commentary on, different components in a bill of material. So this is actually one of the very few things that we were actually able to pull from that other spec. And we did so in a way that is fully compatible with that other spec. Because we're a security standard, we also included signatures. In fact, pretty much everything on here can be digitally signed in addition to the annotations. So this is really just kind of commentary on, and this is human commentary, and you can comment on any object within the BOM. So if you wanted to comment on vulnerabilities or comment on formulation or comment on a component or a service, whatever you want to comment on a license, you can kind of make those annotations. Definitions. This is kind of where CDXA or CycloneDX annotations kind of start. It all kind of starts with a standard and a set of requirements. And you can represent standards no matter what standard it is. You can represent them in CycloneDX. We're actively working with the PCI Security Standards Council to try to get them to adopt this. We have transformed some of their existing standards into CycloneDX format, and we will continue to work with them. All OWASP standards going forward are also going to be represented in this format. So we've got MASVS, which is the Mobile Application Security Verification Standard. They are now releasing their versions of the specification in CycloneDX format. ASVS, which is the Application Security Verification Standard, will also be in their next release producing Cyclone format. Other verification standards like SCVS, the Software Component Verification Standard, is also doing that. And the one that we do need to hit that we haven't hit yet is the OWASP SAM. What is interesting is that SAM, the Software Assurance, what is it? Software Assurance Maturity Model, the ASVS, SCVS, these are all standards that are represented in some cases in their entirety in NIST SSDF, right? So this kind of correlates. This actually can provide a lot of evidence to organizations that you are in fact doing these things and do so in a machine readable way. We've also worked with Synopsys, who has the Build Security in Maturity model, and they will also be providing this in CycloneDX format, from my understanding. Once we have standards in a machine readable format, well, now you can actually make machine readable attestations against those standards. And this really starts out with a bunch of claims, along with any evidence and counter evidence in support of in support of those claims. Now, for each one of these things, you can have different conformance. For example, if you have a requirement that says, well, 100% of my developers have to have yearly security training. Well, maybe I'm only 80% conformant to that because, maybe I've got this one business unit. They're not quite doing it yet. But I do have a mitigation strategy, a poem, to get this up to 100%. So you can express the conformance of 80%. You can also express the mitigation strategies. You can also express, based on the evidence, you can also express the confidence of that evidence. Now, we also support the idea of signatories, right? This is different from like a traditional digital signature. Signatories are kind of like the, for example, a statement such as, I certify to the best of my ability that the above information is correct, type of thing, right? Name, role, signature. And we support not only digital signatures, but analog ones as well. So we support, analog signatures. We support e-signatures, which are not digital signatures, are different. And then, of course, we support digital signatures. The reality is that a lot of CEOs, they don't have their own signing certs, right? We still don't have, after all these years, we still don't have PKI rolled out to every single person in the enterprise, right? It's still not a reality. And then, of course, there's a lot of ways to extend CycloneDX that we'll talk about in a little bit. Serialization formats, again, the JSON schema is the reference implementation for the Ecma standard. But we do have, the other variants as well, XML and protobuf. Because of differences in the serialization formats, they are not 100% aligned to the Ecma or soon to be Ecma standard. But we are keeping them that way for backward compatibility purposes, right? We don't want to break existing things. Now with version 2, right, we can think about version 2, and then we can then think about, aligning all of them, right? So all of them actually are talking about the exact same thing. All right, getting into the specification itself. Again, this is in the root of a BOM. So the location here is the root. This is an object which contains a bunch of different properties. And the first property that is required is the BOM format. And this is always going to be CycloneDX. So you are asserting in the bill of material that this is, in fact, a CycloneDX BOM. In the XML variant, this is done with a namespace, right? The namespace is a CycloneDX namespace. So that would be, for example, one of the differences. But BOM format is how we are expressing this in JSON. Therefore, it's part of the standard. We also have the specification version of CycloneDX. Is it 1.5? Is it 1.1? Is it 1.6? Etc. Now, the serial number and the version kind of work together. Now, both of these things are optional, and they're optional because reproducible builds. Even though the US government, specifically NTIA and the CISA working groups, we intentionally, through consensus, did not want SBOMs to be reproducible, right? According to the reproducible build definition, we did not want these things to be reproducible. Therefore, however, a lot of folks do, therefore these things are optional, right? The serial number and version are optional. But both of these things together form the identity of the BOM, right? The BOM itself has an identity. And that identity is going to be really, really important when we talk about how do we link different BOMs together to express different things. For example, an O-BOM might actually reference an S-BOM and might also reference an H-BOM, right? So the identity of the bill of material is going to be these two fields. This particular one is a UID. This particular one is an integer. And if you ever make modifications to a BOM, right, which is a recognized NTIA framing use case, right, a correction to a BOM, you can just increment the version. You keep the same serial number, you increment the version, and now you are expressing that this is the exact thing, but I've made some modifications to it, right? That's the way to express that. The metadata section, the component section, services. We'll talk about external references in a little bit. Dependencies, composition, vulnerabilities, annotations that we all talked about. Formulation, declarations, definitions, and we'll talk about this in a little bit as well. This is really just the name value thing. This is one of the ways that we can extend Cyclone in a serialization format agnostic way. The unfortunate reality is that JSON schema is, well, it has a lot of limitations. Let's put it that way. In order to have a hardened schema, it is impossible to have a extensible JSON schema, because by default, by design, JSON schema is not extensible. They don't have the concepts of namespaces. So you can't create a hardened schema and be able to express things that you don't know in advance without doing something like this. And this is kind of our way to, we support this in JSON, XML, and protobuf. It's a way to kind of get around the limitations of JSON schema, for example. Also, we support digital signatures in the case of JSON schema or JSON. We support the JSON signature format, JSF. Okay, so that's that. There's the version. Okay, let's talk about the metadata. So this is the first section of the BOM. The date and timestamp when the BOM was created. This is one of the primary reasons why NTIA and pretty much all of us by consensus did not want this to be reproducible. Timestamps were important, but there were other reasons that NTIA never got to, specifically around provenance, that we also didn't want the SBOMs to be reproducible, but we never got around to really discussing those in more detail. So timestamp is when the BOM was created. Lifecycles. This really communicates the stages of the SDLC in which the BOM was created. We support kind of a mix of SDLC and software asset management lifecycles. Tools, these are the things that were used in the creation, enrichment, or validation of the BOM. Manufacturer, we talked about that. And all these things are defined down below too that we're going to talk about in a little bit more detail. So I'm skimming them real quick. Tools, the manufacturer. This is the manufacturer of the BOM itself. Who are the authors of the BOM? The primary component of the BOM. What does the BOM describe? The manufacturer. This was this is a misspelling. This is our equivalent of the HTTP refer, which is also a misspelling, and it's also an IETF standard. But this is deprecated in favor of this one. They also have slightly different meanings. So this one is new as of 1.6. This one is deprecated, has a slightly different meaning, and is misspelled. The supplier, licenses, and this is the licenses of the BOM itself, not the component, but the BOM, because the BOM can have a very different license in terms of use than the component, the software itself, right? So for the timestamp, it's date time. It has to conform to this RFC section 5.6. Pretty self-explanatory. Life cycles, we have a choice here. We've got some predefined life cycles, And we also have the ability to define a custom phase, custom lifecycle. So if you go with the predefined one, so metadata lifecycles phase, you have these phases to choose from. So we've got design, pre-build, build, post-build, operations, discovery, and decommission. With descriptions of all of these. Now, design, pre-build, build, post-build, those are very kind of SDLC-like things. Operations, discovery, these are very SAM or ITAM type of life cycles. Same with decommission. So theoretically, you could describe a BOM that here is an inventory of things that I'm going to be decommissioning. Right? It could be hardware, software, whatever the case is. But a lot of organizations, those life cycles are not necessarily going to meet their needs, right? They might want to go a lot more specific, right? So they can define their own life cycles as well. So give that life cycle a name, give that life cycle phase a description, and we support that use case as well. Now we can also specify the tools that were used in the creation, enrichment, and validation of the BOM, right? And we've got the current way is to use just an array of either components or services. However, we had an older way that we are still supporting that is deprecated that was kind of a subset of a component, right? It had a name version. I think it had external references and hashes. It had a lot of the stuff that a component has. So we were like, well, why are we duplicating this effort? We can't get rid of it, but we can, support something better. So this is the new way of doing it, where we're just specifying the components and services that were used in the creation, enrichment, and validation of the BOM versus the old legacy way of doing it. And let's see, this is the legacy way of doing it. We basically supported vendor name version, hashes, and external references, right? All these things that we also supported in a component. So it didn't make sense to have them in two places. So this part is deprecated. And it will be removed in version 2.0. But we do not have any breaking changes between any of the 1.x releases, right? We do not want people to move from 1.4 to 1.6 and suddenly their BOM is not valid anymore. We are very, very cautious about our backward compatibility. So eventually with 2.0 we will get rid of all the deprecated stuff, but not until then. Okay, these are just descriptions of those fields: vendor name, version, hashes. You're going to see hashes kind of throughout, and it's basically all the same content, right? We basically have an algorithm and the hash value itself, which we call content. These are the hashing algorithms, regardless of whether it's in the tool section, the component section, somewhere else. These are the hashing algorithms that we support. As more become more widely available, we will obviously include support for those things. But this is an enumeration. So when you specify a hash algorithm, it has to be one of these things, right? It can't be something else. And then, of course, the hash values. For the most part, we're going to support every hash value that's out there, whether it's 32, 40, 64, 96, or 128 characters long. We'll support it. Oh, by the way, this is a regular expression pattern. So in some of these fields, we not only have like what the property name is and the type of property it is, but in some cases we will also have a regex so that we can do some validation on it. It should be noted that the entirety of CycloneDX can be validated with JSON schema as well. There is not separate validation that is required to sit on top of CycloneDX, unlike that other specification, which you actually have structural and business logic validation. That doesn't happen with CycloneDX. We have one type of validation which allows us the ability to take advantage of the hundreds of tools that are out there that do JSON or XML validation, right? You don't have to use the official CycloneDX tools to do this, which is a really important takeaway. So if, for example, a highly secure environment, they wanted to, maybe they didn't want to trust in the open source stuff, maybe they don't want to create their own validator, right? So they had proper quality control and rigorous development practices against that thing. Well, they could actually do that, and it would be relatively easy for them to do. External references. Okay, I guess we're going to talk about that in a little bit later, I guess. Where is that defined here? Oh, yeah, it's defined over here. So in a lot of these places, and I think there was an example, there was an example up top as well with components and services. There was a reference to a statement, something like this, right? And that's really so that this document doesn't end up being 3,000 pages long, right? There's no reason for me to have the definition of external references in 40 different places, or the definition of a component in 20 different places, right? So we've got one location in the document where we describe a component or a service, for example, and we're just referring the reader to that particular location in the document.
Is it possible to link there?
With the existing thing, no. We would have to do the linking after the fact. So after this thing is automatically generated, then we could go back and manually link it, is kind of the way it works today. But yeah, I did think about that. Unfortunately, I can't link to, while we're building this documentation, I can't link to something that doesn't exist yet. Is kind of the crux of the problem.
Hey Steve, I have a question. Sorry, I could have raised my hand. Jan also just started talking. Okay, I'll go first. We're looking at the PDF, but we're standardizing the JSON schema. The PDF has examples in it. Are they somewhere in the schema? And then follow-up questions, they are. So they're actually dynamically generated. Are they in like the sections? Like
they are actually the examples, for example, these are actually in the JSON schema itself.
Cool.
Yep.
That's great. Is there a way, or would others also find it interesting to have an example of a CycloneDX xBom like per section or something, just to see it like all together in one overview?
We have, yes, we don't have it in this document. But we do have an entire repository dedicated to BOM examples that we could theoretically include in this document to just refer people to this other repo where all the examples kind of live. Yeah, we can absolutely include that. Let me write that down.
I think this would be particularly interesting because there are a lot of required and optional fields, and going through like that, it's very easy to lose track. And just seeing side by side, this is sort of the minimal part of this area, and this is all the possibilities that this area enables, would, from my perspective, be very valuable.
Okay.
Making it even longer standard.
Yeah, that's okay.
In terms of pages.
It's
right?
it's not going to be that much more, actually.
It's not new content. That's why I'm daring to suggest it.
Yeah. Jan.
Yep. Regarding linking in the document, I thought about it a little bit, and yeah, it would be great. But remember when we put this thing printed on paper somewhere in a library in the Arctic or somewhere, so that people in 200 years from now on could still read it, they probably don't know how to click on that blue text on their papers. So I think maybe we should somewhere state how these locations are to be read, or maybe yeah, we could color them in, but it's still, even if they are links, we should somewhere establish that these are cross references.
Yeah, the table of contents is
probably-
actually linkable.
Yeah, I've seen that, but I mean there are page numbers on it, so I could still get
Right.
to that section, and still we have section numbers here and there in the document. So, like you said, I find it very cool to note that a location is seen as a reference or referenceable, which is even better than having these section numbers like 2.3.3.5.1.0, which is auto generated. So yeah, when we're doing like this reference thing, maybe have it somewhere mentioned how the references are to be read and how to be applied.
Mm.
Just, I mean, we know it because you explained it beforehand, but yeah, just an idea.
Got it. Okay, I got both of those notes. Thank you both for that. Were there any other questions? We've got, well, we're running up on time. We've got 4 minutes left. Let's see how much we can kind of get through external references. All right, we can get through at least this. So this is the manufacturer of the bomb. And a lot of the, well, most of the objects within the bomb has what's called a bom-ref. This thing right here, and you're going to see this throughout the specification. It's kind of a really important aspect of CycloneDX. This is really the identifier of this bomb, of this object within the context of the bomb. Every bom-ref within a bomb needs to be unique. We recommend that they be UIDs or package URLs or something like that. For components, for example, that could be package URLs. But, and this is where the identity really comes into play, and we'll talk about that later on in a different section. But you can actually establish relationships to different things in a bomb using something called Bom-Link. And this is where the serial number and version are really, really important. Because not only can you reference something within the same bomb, but you can also reference things across other bombs. So if you wanted to reference a manufacturer in a different bomb, you could theoretically do that. But this is the identifier of this particular object in this bomb. Name, address, URL, contact, pretty self-explanatory. The address is, okay, so this is the bom-ref. The name, again, there's examples. This is all in JSON schema as well. This is the address. This is new as of 1.6. So we've aligned, I think Matt aligned this with, what was it, schema.org, I believe?
Schema.org.
Yeah. So this aligns to the schema.org specification for address. Again, we've got a bom-ref, unique identifier of this object within the bomb. Country, region, locality, post office box number, postal code, and street address, all optional. And let me mark this as kind of our ending place for today. So we are at time. I think we've made some good progress. Was this show of hands, I guess, or shout outs? Is this useful? Are you finding this valuable? Yeah.
Yes.
Okay.
Yes.
I definitely did more
great.
interesting, valuable than I expected.
Okay.
Yes.
It's amazing
Fantastic.
how you can monologue on this. You're going to monologue for 13 hours
I'm gonna-
straight.
I'm glad we Well, yeah, I'm glad we cut this up into shorter 1 hour meetings. Otherwise, by the end of that 5th hour, my voice would have been toast.
We could have the Steve Spring Labor Day telethon.
Oh
Yeah.
no, let's not do that. Let's not. All
And
right.
Steve, you've got over 600 pages, many hours.
Yes,
That's
this is going to
excellent.
take a while. Okay, well, good. We'll get through it. We'll, again, it's not just about getting through it. It's really about raising the competency of the spec for everyone to be really comfortable with it. So again, this is not for my benefit. If there's any questions, even if it's offline, just kind of let me know. All right.
Thank you. Yeah.
With
thank you
that,
for
everyone.
this.
All right, very good. Have a great rest of your day, and we'll catch you all soon. Cheers.
You too.
Bye.
Thanks, Steve.
Cheers.